We started talking about fine and heavy chemicals the previous time. Now, today we'll be continuing with fine and heavy chemicals. Actually, that day I came back. I guess maybe you didn't get information that I was back.
Yes.
Um, so we'll just go through what we did before then. So we'll just build on what we've done again. We were talking about chemical industries, and I said a chemical industry is an industry that uses the principle of chemistry to convert raw materials into useful products. They use the principle of chemistry to convert raw materials into useful products. And the last time we also talked about factors to be considered in citing a chemical industry. I did mention that one of those factors are nearness to source of materials. We can have a material, we can have raw materials closer to us at in Port Harcourt here. I will be citing the industry in Lagos. It's not possible. Definitely, it has to be very, very close. So, one of the things is nearness to source of materials. That's why most petroleum industries were formerly in Port Harcourt around the South region because of we have petroleum crude oil around the South areas. Another thing I did mention was energy. Energy, fuel, power supply is needed as a factor. The energy, power, or fuel supply is really needed. Okay, energy is needed, the power is needed. Another thing that we talked about was the human resource, which is the labor force. Robots will not be the one working. Even if robots were to be the one working, you can't overrule human forces. We are getting to an age now where humans would not be the one working. But trust me, there's no way we can overrule the fact that humans must still be the one to work because humans needs to control or direct the robots. Humans would need to direct the robots, tell the robots what to do, how to do, program the robot to do something. So the robot would not just start doing things on its own. So human resources cannot be overruled. Another thing we considered was transportation costs. The cost of transportation, transporting it from one end to another. That's why most companies have decided to use the pipeline to transport oil from one area to another because pipeline to them seems to be the fastest for them. Okay, another thing is nearness to the market. When citing a chemical industry, nearness to the market to get the materials, and another one is nearness to source of water. For example, those that will be dealing with those that make soap, they can never do without water. Those that need that make chemicals, food, beverages, they can't do without water. Water is a primary source. That's why you see most electrical company, most electrical company, you notice they are most times close to the riverine areas because they make use of hydroelectric power. Okay. Another thing else is a conducive climate. Yeah, conducive climate can also be part of them. Now, we also said chemical industries are easily categorized based on the type of products they manufacture, different kinds of products. Did we mention that last time?
No.
Okay, okay. Please write this, that chemical industries can be easily categorized based on the type of products they manufacture, based on the kind of products, on the type of products they manufacture, based on the type of products they manufacture. Then we have about 13 of them. We have about 13 of those things, 13 of those industries based on the kind of products they manufacture. So number one, we have the heavy chemical industries. Heavy chemical industries. Okay, I'm just going to call the list of all the industries. Then I'm going to take them one by one to explain. Okay, we have number one, heavy chemical industries. Number two, fine chemical industries. Fine, Fine, fine chemical industries. Number three, the pharmaceutical industries. Number four, the fertilizer industries. The next one, cement industries. Number six, ceramic industries. Number seven, the plastic industries. Number eight, food and beverages industries. The next one is glass industries. Metallurgical industries. The next one is paint industries. Okay. The next one is soap and detergent industries. And next one is cosmetic industries. Were you able to get them?
Yes, sir.
Okay. Now let's talk about the fine and the fine and heavy chemicals. The fine and heavy chemicals. Okay, now let's talk about the heavy chemical industry, heavy chemical industries. Now, when we talk about heavy chemical industries, we're actually talking about these are industries, right? These industries produce chemicals as raw materials. These industries produce chemicals used as raw materials by other chemical industries. These industries produce chemicals used as raw materials by other chemical industries. Okay? Please write this part also. Their products are usually manufactured in large quantities. Their products are usually manufactured. Their products are usually manufactured in large quantities. Okay? Because many industries depend on their products. Because many industries depend on their product. Because many industries depend on their product. Uh, Now, because many industries depend on their product and they're also in high demand. So what happened? They are manufactured in larger quantities. Now, example of some heavy chemicals are some of these heavy chemicals they include tetraoxosulfate 6 acid, H2SO4. Now it is used in fertilizers industry, H2SO4. And another example of heavy chemicals are sodium hydroxide. Wow, sodium hydroxide is and potassium hydroxide are needed in soap making. They're needed in soap making. They're needed in making fiber and paper industries. Um, there are also another example of these sodium trioxocarbonate 4, that's Natuco 3. Natuco 3, they are used in glass. detergents, and waterworks. Natuco 3 is part of the heavy chemical industries. Another example of these materials, we have sulfur 4 oxide. That's SO2. Sulfur 4 oxide can be used in the manufacture of H2SO4. So 4 oxide, we use that in the manufacture of H2SO4. Oh, another important one which we may not or cannot do, we cannot just overrule is chlorine. Chlorine, though is poisonous, is dangerous, but it's still very important. What is chlorine used for? Chlorine is used in textile and paper industries. Chlorine is also used for bleach. That's what we use in our bleach, the hypo stuff. You'll be seeing something like hypoxychlorate. So chlorine, very, very important, right? Um, there's another thing that's very important. Oh, because we'll be using that for our baking powder industries. That is sodium hydrogen trioxocarbonate, NaHCO3, sodium hydrogen trioxocarbonate. This is used in baking powder industries for making baking powder. So you see, these are examples of heavy chemical industries. People need them. They need them. Once this baking powder is being used, is being produced, they now send them to other, probably those that would sell baking stuff. So people that want to make cake will have to go to the other industry, but the other industry goes to the major people that makes them in larger quantities. So they make the raw materials, then these other ones start selling them, and then the other people, the baker, goes to the other lesser industries to buy their baking things. Okay, number two, let's talk about fine chemical industries. Fine chemicals industries. Okay, now if heavy chemicals are produced in larger quantities, I said something that if heavy chemicals are chemicals produced in larger quantities, okay, so fine chemicals are chemicals produced in smaller quantities. Fine chemicals are produced in smaller quantities than heavy chemical. Are produced in smaller quantities than heavy chemical, but they are also important. But they are also important. Now, why are these industries produced in smaller quantities, right? These industries pay great attention to purity products. These industries pay great attention to purity products because the chemicals are used for sensitive and specific purposes. These industries pay great attention to purity products because the chemicals are used for sensitive and specific purposes. Now, most times, some of these products, they include they include the drugs, the cosmetics, the cosmetics, most times the additive for vehicle engine performance. Remember, we talked about octane rating. So that's an example, the additive for vehicle engine performance, and also analytical reagents are also examples of fine chemicals. That's what we use in the lab. You see, those things that they use in the chemistry lab, they go to fine chemical industries to buy them because they are producing smaller quantities. Okay. The next one, it's pharmaceutical industries. Pharmaceutical industries. Now, pharmaceutical industries, they produce various chemicals used in the hospital. They produce various chemicals used in the industry. I mean, sorry, used in the hospital. They produce various chemicals used in the hospital. An example of such chemical that are used in the hospital, number one example is the sedative. Sedative. Now, a sedative, when somebody is having, when somebody is behaving abnormally, or they need to, somebody is very hyperactive, and maybe not allowing them, maybe they want to carry out surgery, and the person is always, no way, we can't do this for me. You just have to sedate the person. Now, what's the component of a sedative? It's actually potassium bromide. Potassium bromide. That potassium bromide is sedative. What's potassium bromide? Remember, potassium is K, bromine is Br. So KBr, potassium bromide. Now, another one that's very important is mercury 2 nitrate. Mercury 2 nitrate. Mercury 2 nitrate is used as an antiseptic for skin disease. When someone has a skin disease, they give that person mercury 2 nitrate 5. Mercury 2 nitrate 5. Wow. Something very important again is the plaster of Paris, POP.
Answer.
You said?
Nothing.
Okay. The plaster of Paris. Now, the plaster of Paris, what's the component of plaster of Paris? Is calcium sulfate. Calcium sulfate, that is CaSO4. CaSO4, calcium sulfate. Now, that's calcium tetraoxosulfate 6. And the next one is iodine, very important. Iodine for injuries, very, very important. Antibiotics, antibiotics, awesome. Antibiotics used probably for fighting and things like chicken pox, measles, and others. The next one is insulin. Insulin for diabetic patients. Insulin, very insulin is important. Okay, and okay, that's all we can give for now on for the pharmaceutical industries, chemicals used in pharmaceutical industries. All right. The next one we'll be having it's the fertilizer industry. The fertilizer industry. Now, these guys are responsible for producing fertilizer of various grades. They produce fertilizer of various grades, and also they also produce, okay, they produce fertilizer of various grades. We have ammonium sulfate, that's ammonium tetraoxosulfate 6, NH4 2, that's in brackets 2SO4, ammonium tetraoxosulfate 6. We also have ammonium trioxonitrate 5, that's NH4NO3, NH4NO3. Fertilizer industries. Yes, I said the fertilizer industries, these industries, they produce various they produce various fertilizers. They produce fertilizers of various grades. They produce fertilizers of various grades. An example of such fertilizer is ammonium tetraoxosulfate 6. Ammonium tetraoxosulfate 6, that's NH4 in brackets 2SO4. Ammonium tetraoxosulfate 6. Okay. The next one we have, it's ammonium trioxonitrate 5. Ammonium trioxonitrate 5, NH4NO3, NH4N, NH4NO3. Now, they also produce pesticides, germicides, herbicides, and fungicides. I said they produce pesticides, produce germicides for fighting out the germs, the herbicides, and the fungicides. Okay, these are what the fertilizer industry guys they do. Now the next set of industry. Okay, did you get that, please?
Yes, sir.
Okay, the next set of things people will be looking at is the cement industries. The cement industries are very important to us. Why? Because their products are used in constructions. They use their products in construction. They use their products in the construction industries. We can use them for building bridges, house roads, drainages. Okay, so cement is very, very important. Maybe that's why the richest black person now in Africa is still Dangote, because of the cement is needed virtually everywhere. We can't do without it. Okay, they're used in building bridges. We use that in building for houses, construction of roads, construction of drainages. Cement, very important. Now, one thing about cement is that it becomes a very hard substance when it is mixed with water, sand, and gravel. Now, are the what are the composition of cement? Now, cement contains number one, quicklime powder, quicklime. Cement contains number one, quicklime powder. What's quicklime powder? That's calcium oxide, CaO, calcium oxide, number one. Number two, cement contains clay, clay, okay? What is clay? Clay is silicon 4 oxide, that's SiO2, silicon 4 oxide, and some aluminum oxide. Can you guess what aluminum oxide is? Can you give me the formula? Al2,
O3.
okay, Al2O3, awesome, awesome. Okay, now Al2O3, that's aluminum oxide. Now, all these chemicals are obtained naturally from the earth in form of limestone. All these chemicals are obtained from the earth in form of limestone. And most times when they are heated, now limestone is actually CaCO3, that's calcium trioxocarbonate. Calcium trioxocarbonate 4, calcium trioxocarbonate 4. Most of these chemicals are obtained from limestone. And when limestone is heated strongly, the limestone changes to quicklime, that means CaO, and carbon 4 oxide, CO2. Okay, so that's the cement industries. That's the cement industry. Okay. The next thing we'll be looking at is the plastic industry. The plastic industry. Okay. Now, the plastic industry uses organic compounds, like ethene, ethine, like ethene, ethine, phenol, ethene, ethine, phenol, benzene, and styrene. Styrene is spelled styrene is spelled Styrene. Styrene. Now, these organic compounds are obtained from petroleum. These organic compounds are obtained from petroleum and coal tar industries. To make plastics. They're obtained from petroleum and coal tar industries to make plastics. Use that to make plastics. Now, the plastics could be in form of pellets or granules. Now, other raw materials that we use for plastics are other raw materials. Other raw materials that we use for plastics, number one, we have the phenol, we have cellulose, and we have the vinyl chloride. We call that PVC when it is polyvinyl chloride, PVC, but it started with vinyl chloride. The vinyl chloride is spelled VINYL. VINYL. Okay, but when it is in in large quantities, like in many, that's what we call polyvinyl chloride, PVC. Right now, we have two main types of plastics. Number one, we have the thermoset, and we have the thermoplastic. Thermoset and thermoplastic. Now, what is thermoplastic? Thermoplastic materials, now they involve, number one, why do we call them thermoplastic? Now, thermoplastic materials are these materials that can be remolded they can be remolded after melting. Now, when you melt them, you can remold them back to something else. An example of such is the plastic bottles. Um, the thermoplastic. An example of such thermoplastic we have example of such thermoplastic I said we have the plastic bottles, the polythene bags, and other materials, household. We have other ones. Now, one thing we should know about these guys, these thermoplastic materials, is that they can be recycled by some factories to form other materials. They can actually be recycled to form other materials for human use. Okay, your bottles are not still in waste. That's your plastic bottles are not still wasted. Okay. Another one, we said thermoplastic. Now, the next one we have is the thermoset plastic. The thermoset. The thermosets, now we call them thermoset because they cannot be recycled. They are stronger and they are more durable. They cannot be recycled. Rather, they are stronger, more durable, and most times they are used for furniture making. So these guys cannot be recycled. Once they're damaged, we can't use them. We can't use them. Some of all these plastics were remolded, but once they become thermosets, most times they can't be used again. Okay, so that's the types of plastic, the thermoplastic and the thermosets. Okay, the next industry we'll be looking at is the glass industry. Glass industry. Now, glass most time is made from sand, and it is cheap when compared with other materials. Now, we remember when we talked about clay, we said clay consists of silicon 4 oxide. So that means the silicon 4 oxide in sand, when treated with with other chemical like lead. Now, what I said was the silicon 4 oxide in sand is treated with other chemical like lead. Now, when it's treated like with other chemicals like lead from glass, these industries produce a lot of materials like the glass waves. That's when we talk about the glass waves, I'm talking about the glass cups, the glass bowl, the window pans. They produce the laboratory wares and apparatus, light bulbs and mirrors. So they are treated. Now, the glass most times can be colored or transparent depending on its use. Can be colored or transparent depending on its use. Okay, now let's talk about raw materials. Let's talk about raw materials. Raw materials. Okay, now what are raw materials? What do you understand by raw materials? What do you think? We always talk about raw materials. Can you give me a clue to what you know about raw materials?
Raw materials are natural resources used to make
I didn't get that. You said what, please?
things. Raw materials. Raw materials are natural resources.
Okay, they are natural resources. Okay, yeah, um, they could be natural and non-natural. Okay, let's take this. Raw materials are starting material ingredients. Raw materials are starting material ingredients. That means they are the first material ingredients used for manufacturing. Raw materials are the starting material ingredients. H2SO, now the raw material for an industry might be the product for another industry. Okay, it could be some another industry needs ammonia. Another industry needs ammonia. Okay, ammonia could be the raw material for one industry, but it could just be the product. Okay, the job guys that make ammonia using the industrial preparation might just react. Okay, we need um, 3 molecules of 2 molecules of ammonia, or of nitrogen, and this other molecule of hydrogen to give you ammonia. That's a raw material. That's a product for them. Ammonia becomes a product for them. But for another industry, maybe making soap, they might decide, oh, ammonia is a raw material for us. That's just it. Sodium hydroxide is a raw material for soap industry, but the industry that produces sodium hydroxide, that is the heavy chemical industries, sodium hydroxide is just it's just one of their products. Do you understand what I'm saying?
Yes, sir.
Okay. Another example is the raw material for plastic industries are the raw materials are just product of petroleum. The raw materials for plastic industry, probably one of them is bitumen. Maybe for plastic industry, bitumen, maybe those asphalt, but those are just products of the petroleum industry. Now, most primary or raw materials are obtained from nature. An example is petroleum is obtained from nature. The metal ores are obtained from nature. We did not create them. Common salt from the sea, that's sodium chloride, is obtained from nature. That's common salt from the sea. Um, Coal is obtained from nature. We did not create them. All right. Limestone. Limestone is obtained from nature also. Clay and sand, they are obtained from nature. We did we don't own them. So now these raw materials are used to produce other materials or chemicals that are used to produce other materials or chemicals. Now, I have an example of what I have here. It's you draw a kind of a table. You draw a table. We have natural or raw materials, one hand. We are going to put chemicals gotten from it, one table, and the other ones are materials. Do you understand what I said?
Yes, sir.
Okay. It's going to be like a table form. To be like a table form.
From it and
Yeah, natural or raw materials, that's one hand. Um, some chemical gotten from it, and the other one are the materials. Okay. Now, if you have done that, the next thing you do is the raw materials. Number one, petroleum. Now, what are the chemicals gotten from petroleum? We have the petrochemicals. Petrochemicals like e.g. we have the ethane, we have the ethene. That's ethane, ethane. The other one is ene, ethene, and we have benzene. We also have many other products from there. Okay, the materials now, what can they be used for? Plastics can be used to make pesticides. It can be used to make beverages. It can be used to make fertilizers. And alcanol, that's alcohol. Alcanols, then you put in brackets alcohol. Okay. Now, now raw materials now, natural raw materials from nature. We have the earth, the earth itself. Now, in the earth, we have the chemicals gotten. We have limestone. What are limestone used for? Under limestone, please, in the next place, that's the in the next place in limestone, that's the materials for limestone. Put cement. Okay, let's come back to other some chemical gotten from the earth again. We have metal ores, the ores of metal ores. Now, under materials for metal ores, what can be gotten from it? We have, or what can it be used for? Containers, containers, roofing sheets, vehicle bodies, vehicle bodies. These are materials from metal ores. Okay. Now, that's from the earth, we have number one, limestone. Number two, metal ores. Number three, clay or sand. Clay or sand. Now, what are the materials gotten from clay or sand? We have ceramic products like floor, the floor, the floor tiles, the floor tiles. We have the bathtub, the bathtub. We also have the toilet bowls, the toilet bowls. These are gotten from the earth under clay or sand. All right. Now under the natural raw materials, we have the petroleum, we have earth. Number three, we have plants. We have plants. Okay. So what are the things gotten from the plant? We have three things gotten, the three chemicals that three things that be gotten from the plant. Number one, we have the palm oil. Palm oil. Okay. What can palm oil be? What are the materials we use palm oil for? Palm oil can be used in soap making and can also be used as margarine. Okay, we have the palm oil. Now, under materials in palm oil, we have soap and margarine. Have you written that? Have you gotten that?
Yes, sir.
Okay. After palm oil, we have cocoa. Cocoa, the materials that can be used from cocoa, we have the chocolates and beverages. Chocolates and beverages. Okay. From the plants, we have palm oil, cocoa, and the next one is rubber. That's not the last. We can get many other things from plants. Next thing is rubber. We can, what are the materials gotten from rubber? We have tires and other rubber products. Tires and other rubber products. Remember, from plants also, we can get timber. From plants, we can also get timber, and timber is used for furniture making. Can also get from the plant, we can get timber. Timber can be used for furniture making. There are many other things we can get from plants. Okay, from the sea, we can get the common salt, which is sodium chloride. Common salt, which is sodium chloride. Okay, and the materials gotten from there can be used as seasoning for cooking. Seasoning for cooking and materials for other chemicals. Materials for other chemicals. Funny enough, we can actually use sodium chloride in soap making also. So, but it can also be used as starting materials for other chemicals. All right. The last one we'll be talking about is the air. The air, natural raw materials, the air. What are the things that can be gotten from the air? We have oxygen. Oxygen. Wow, the word is blessed. We have the earth, the land, and the sea, the air. Wow, we have too many things that we can get hold of. Now we have oxygen. What's oxygen used for? Oxygen is used in welding. In welding, oxygen is mixed with ethylene. That's ethene to produce the oxyacetylene flame. That thing they use in welding. Those guys that weld, they use oxygen and acetylene. That's ethine. So oxygen is used in welding and in hospitals. Hospitals. When somebody cannot breathe, just give them oxygen to breathe. Okay. The next thing we have it's the nitrogen. nitrogen is used to produce ammonia. Nitrogen is used to produce ammonia. And ammonia is very important, is a starting material for manufacture of fertilizers. So fertilizer industry needs ammonia. So they will always patronize those guys that produce, that get nitrogen and use it for production of ammonia. All right. Have you gotten that?
Yes, sir.
Okay, I have this little question to ask you. In which chemical industry would you associate paracetamol? Paracetamol, well, which chemical industries would you associate that?
Pharmaceutical,
How about baby powder?
cosmetic,
Cosmetic, yogurt.
food and beverages.
Sorry?
Food and beverages.
Okay, food and beverages, correct. All right, the next one is name one industry that utilizes ethane as raw materials.
Cement.
Cement, ethane? No, they don't use cement. Really? Is
Yeah.
cement their raw material? Not really.
Glass.
Sorry?
Glass.
Glass? No. Glass, is it their raw material? Not really. Glass is majorly made from sand. That's silicon. So, you're close. You're close.
Ceramic.
Sorry?
Ceramic.
Ceramic? They use that? Not really. Ceramic is not so all about that. You're almost close. You're almost passing the. You're almost passing it. You're almost close. Oh.
Plastic.
Plastic, correct. Plastics are from petrochemicals. Because they are from petrochemicals, ethane will be used. Uh, ethane will be used as a starting raw materials. Okay. Okay. The next one is let's look at the importance of chemical industries. Importance of chemical industries. Number one, um, we have the importance of chemical industries, A, to an individual, and B, to the nation. Okay, to an individual. Let's look at the importance of chemical industries to an individual. One thing we know about chemical industries is number one, they provide employment. Provide employment. They provide employment for both skilled and unskilled. Wow, whatever way. Yeah, we can never do, even if we can never do without even those guys that are unskilled, because the skilled guys will be leaving for better ones, the unskilled ones will be coming back. So they provide employment for those skilled and unskilled. Okay. They are also They are also used for treating woods, WOODS. They are also used for treating woods. Okay. B, let's look at to the nation. They provide earnings from foreign trade. They provide earnings from foreign trade. From foreign trade. Okay. And another thing else we should note about this is that chemical industries improve the standard of living of any country by providing many materials for domestic use. They improve the standard of living. Now, improving the standard of living, most times we import, if we start importing too many things, imagine in Nigeria, what we use for making our cream, we start importing them from China. When we can just make them, Nigeria is blessed with petroleum, and China does not have petroleum. But one thing they do is they buy petroleum from people, other countries that have, and the petroleum they buy, they make use of it so well in making petrochemicals, creams, many other things that most times we in Nigeria we go to buy from them again at very expensive rates. I want to ask you this: if you notice, you discover that processed form of anything. Sorry, can you hear me?
Yes, sir.
Okay, the processed form of anything is very, very expensive compared to the raw form of anything. Let's take, for example, let's take natural things, yam and pounded yam. A tuber of yam can be sold for 100 naira, but just one handful of pounded yam can be sold for 500 naira. Let's take another example, plantain and fried plantain or plantain chips. We can actually buy plantain for 500 naira, a very big one, a bunch, but a handful of plantain can be sold, plantain chips can be sold for 100 naira. Now, another thing, it's cocoa and Milo. You can actually buy cocoa for probably 1,000 naira, but just one tin of Milo can be sold for, I think it's sold for 1.5 now or 1.2. So if you notice that the processed form of anything is so expensive. So imagine China comes to Nigeria, buys our oil probably for um, maybe $25,000 per barrel or to $1,000 per barrel. When they buy that, they go to their country, process it into tire making. They make tires from petrochemicals. There are a whole lot of things you can make from petroleum. The petrochemicals make oxyacetylene flame we use in welding, make the creams, make the detergents, make many other things, and then they bring it back to Nigeria for us to buy. Now we start paying lots of money for these things that we have the starting material here in Nigeria. That's just the problem of Nigeria, that we sell our important raw materials, and we go outside to buy the finished product from them. Okay, so that's why I said they can improve the standard of living of any country. Let's look at the environmental problems created by chemical industry. Environmental problems created by chemical industry. Yes, they are awesome. They do well for us, but nevertheless, we cannot overrule the fact that chemical industries have also caused some environmental problem. Some environmental problem. An example of such is some years ago, it was said that I think that should be either in China or Japan, that they just woke up to discover that all the fishes in the sea died. They saw dead fishes floating on the river. And all they noticed was that when they traced it, it was from an industry that I think they didn't know, but they were expelling either mercury or gamalin 20. They were expelling it out of the industries into the river. And due to that, when chemicals have been expelled into the river, um, fishes, aquatic animals, they need oxygen to breathe. Just the way if you were placed in a room with the exhaust of a fuel, I mean the exhaust of a generator or a motor car inside your room. When you are placed in the room and everywhere is closed, you suffer due to lack of oxygen, and that person would die due to carbon dioxide being released into the room, and there's no way you can breathe. The same thing happens for aquatic plants, in that when chemicals are being released, when petroleum and other chemicals are being released into the seawater, they block the airways for fishes to breathe, for aquatic plants to breathe. So this, I remember when oil goes into water, it forms what you call an emulsion in water, and they start spreading themselves. The fishes run away from those areas, and if it becomes in larger quantities, the fishes, they die due to lack of oxygen. So that was what happened. Now, that's one of the adverse effects of chemical industry. So number one, their waste can contaminate the air we breathe and the water we drink. Their waste can contaminate the air we breathe and the water we drink. Very, very important. The air we breathe can be contaminated. The water, the water we drink also, because most times they are being released into the sea. In fact, I pity the sea animals because they suffer from it. Most times their liquid waste are just dispelled into the river, just like that, until some organizations start coming in place to look at what they do, the kind of waste that must be expelled into the river now must be a less harmful waste to it must be treated. Even the waste has to be treated now before it's being released into the sea. I don't know if it's still obtainable. Um, that's very, very important. If you notice in your lab, I wouldn't know if you have that. There's something called a fume cupboard. A fume cupboard. I don't know. Have you seen something like that in your lab before?
No.
Okay, a fume cupboard is actually most times some people make it like a glass. What a fume cupboard is used for preparing dangerous chemicals. An example is chlorine. If you'll be pouring chlorine in the lab, you shouldn't do that outside. Chlorine are poisonous gases. The fume cupboard, most times, I think I've used it for H2S, that's sodium hydrogen sulfide, because it smells like rotten egg. Now, if once a fume cupboard is done, it expels, instead of it filling the room of your laboratory, you prepare it in the fume cupboard, and it expels the air outside. It expels it. Okay. Number two, It is also noisy. It is also noisy. Now, if there's a chemical industry around, that's why most chemical industries are not sited around where people live. Around where people live. They are sited very far away from where people live. If you notice, cement industries, you see them very far. Most times they could be at the outskirts of any place wherever they are. So these are um, these are some environmental problems created by chemical industries. Okay, I have some questions here. I have some question here. An elastic rubber is formed by a process known as an elastic rubber. Okay, let me share this question with you then. Coming. All right. Shared. Can you see the first one?
Yes, sir.
Okay. An elastic rubber is a process, is formed by a process known as what?
Polymerization.
Sorry?
Polymerization.
Polymerization. Okay, I like the fact that you said something as regarding that. Okay, polymerization is actually the bringing combination of monomers to form small molecules of hydrocarbon called monomers to form larger molecules of hydrocarbon to form that's polymers. So it cannot be polymerization. Um, Thermoplasticity is just the types of, and thermosetting are just types of rubbers. So it cannot be polymerization. It cannot be thermosetting. It cannot be thermoplasticity. The answer is actually vulcanization. Vulcanization, the process of making rubber. Okay, that's just the simplest definition, or a layman's definition of it. You'll be doing more of that in your higher grade. Okay, number two. Factors which can contribute to environmental pollution include environmental pollution include said overpopulation. What's C? C is overpopulation, chemical warfare. Okay, okay, C, correct. Number three,
D.
one of the adverse effects of chemical industry in the community is okay, D, correct.
D.
Number four,
A.
A, ethanol. Are you sure?
Sorry. D. 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 D.
D, yeah, ethane. Ethene, yep. Okay, number 5. Okay,
D.
you said
D.
Did you say C?
D.
D, correct. Ethene. Tetrasulfate 6 is a heavy chemical. Caustic soda is also known as sodium hydroxide. Um, Sodium trioxocarbonate. These are all heavy. These are just heavy ones. So that is actually correct. Okay. I think I'm going to give you these essay questions as assignments. Can you write that down?
Okay.
There's a periodic table. Okay, on that periodic table, the first thing we'll be looking at is what is periodic table? What is periodic table? Okay, what do you understand by periodic table? You've been hearing of periodic table. In fact, it's one of the most common elements or most common assets you should have in chemistry class. So, what do you understand about periodic table? Just tell me anything you know.
Periodic table is a table of chemical elements in
Sorry?
which the elements are arranged in order of atomic number.
I didn't get that, please.
Periodic table is a table of chemical elements in which the elements are arranged according to the order of atomic number.
Okay. Now, one thing we should know about periodic table is number one, or just write this. Periodic table shows the arrangement or grouping of elements. Periodic table shows the arrangement or grouping of elements in order of increasing atomic number. Periodic table shows the arrangement or grouping of elements in order of increasing atomic number. In order of increasing atomic number. What we are trying to say is that the elements are only the elements are only arranged with the fact that the atomic number with higher increasing atomic number, starting from the to the highest. As of now, we have about 106 elements. We know we have 106 elements. So from the lowest to the highest, that's what periodic table is. Okay, now let's come to periodic law. Periodic law states that the properties of elements the properties of elements, are a periodic function of their atomic number. The properties of elements are the periodic function of their atomic number. One of these things trying to tell us is that
So you said it's the properties of elements.
the properties of the elements are the periodic function of their atomic number. The properties of elements are the periodic function of their atomic number. What this is trying to make us understand is that the atomic number tells us much about the property of that element. An element with atomic number 1 tells us a lot. About it. An element with atomic number 2 tells us a lot about it. Okay, now we would be looking at what that's electronic configuration. Electronic configuration. Electronic configuration. Okay, please write something this about electronic configuration. Now, electronic configuration of an atom is the representation of the arrangement of the electron. Electronic configuration is the representation of the arrangement of the electron distributed among the orbital shells. All right, yeah, I said electronic configuration is the representation of the arrangement of the electron. Is the representation of the arrangement of the electron distributed among the orbital shells and subshell. Distributed among the orbital shell and subshell. Okay. Let's just use one example, and I think we'll just stick with that. For example, if I'm to use carbon, carbon has atomic number 6. So we are going to be having 2, 4. All right, that means it's going to have 2 shells. 1, 2. Oh. 1, 2, 1, 2. It also says a lot about the orbital shell. We have 1, 2. Then we draw another one. 1. Put it. That's not the end. We can also decide to put 1s2, 2s2. Can also say 2p. Have you done something like this before?
Yes.
Okay. 2p2. Now this tells us a lot that this guy is going to belong to the P block on the periodic table. He will belong to the P block in the periodic table. Now you can see now that an atom, just the atomic number, has given us a whole lot. Has given us a whole lot about the name carbon. Carbon has given us a whole lot of carbon. So that's what we are trying to say, is that the properties of elements are the periodic function of the atomic number, the periodic table, that just one carbon alone, we are able to know that carbon, okay, belongs to, in fact, we will still go further. I think I've told you how to get the groups and period, right?
Yes.
Okay. So these are great, these are amazing, these amazing things, amazing ways of getting the atomic number, uh, talking about the properties of these elements, what it entails. So we've just been able to bring this fact that, okay, this thing now, this thing alone has brought us to what we call hybridization. This thing alone is all about hybridization. This one alone has given us that. This one alone has given us that it belongs to the P block, and this now tells us that it's, sorry. So this is what we've been trying to say, that this alone has given us what this is about. 1s to 2s2. These two alone, this P means that this is the block. 2 alone tells us a lot. This 2 means a lot to us, means a lot already to us. So that's all we are trying to say, that, okay, this one alone is ready. This is the S block. This is one P block, S block, and a P block. So we are trying to understand. We're trying to understand this, that this is exactly what it would entail. You take up another element. You take up another element of. You take up another element of oxygen. Sorry, let me use another color. Oxygen. Oxygen belongs to 8, and that's 2. Okay, let me clear the drawing. Oxygen. Okay, we take up oxygen, atomic number 8, 2,6. Right, oxygen has for oxygen, we draw the first one, then we draw the other one, and then we can say for oxygen we have the electrons. Now the electrons in the outermost shell, we first put 1, 2, 3, 4. Let's go it again. 5, 6. Now, this one now shows that oxygen has 2 unpaired electrons. To complete this, oxygen has 2 unpaired electrons, all right? Okay, we also have 1s2, 2s2, 2p. This will be how many? 4, right? Isn't it? Okay, so this is just an example of what we're trying to say, that the electronic configuration and the periodic table, which is the arrangement, the periodic law, which says that the properties of elements are uh, the properties, which states that the properties of elements are periodic function of their atomic number. Okay, one of the things we must understand is that we have an orbital SPDF. SPDF. Okay, we know that the s orbital can contain the s orbital does not have a suborbital, does not have suborbital. What are we trying to say? Let me show you that. Let me show you that in a minute. Now, the s orbital does not have suborbital, but it can contain two electrons. Now we have sp d f. You have SPDF. This guy does not have any suborbital, but it can contain two electrons, just two electrons, so it does not have any suborbital. P has three suborbital, but it can contain a maximum of 6 electrons. 6 electrons. Now D has just 5 suborbital, but it can contain a maximum of 10 electrons. And F can contain 7 suborbital, but it can has a maximum of 14 electrons. Okay, but S does not have any suborbital. All right. Okay, so that is orbital. Now, I didn't tell you what orbital is. Please write this thing about orbital. An orbital is a region of space around the nucleus. An orbital is a region of space around the nucleus. An orbital is a region of space around the nucleus where there's high probability of finding electron. Where there's high probability of finding electron. Okay, now in our next class, I'm going to explain, in our next class, I'm going to go over this again, but I will be talking about the rules and principles of filling electron. The rules and principle of filling electron. The rules and principle of filling electron. So, well, please write this. I didn't give you this. That the s orbital, the shape of the s orbital is spherical. Please write. I want to talk about the shape of SPDF. The s orbital is spherical. The p orbital is dumbbell. The s orbital is spherical. The p orbital is dumbbell. The d orbital is double dumbbell. And the f orbital is complex. Okay, you've gotten it, right? Have you gotten that?
Yes, sir.
Yeah, okay. I guess we're going to stop here. Tomorrow we'll continue with that's by 4 o'clock, right?
Yes.
All right, let's pray. So I'll give you an assignment. You can work with that. Let's pray. Father, we thank you. We give you thanks for everything. Thank you for wisdom. Thank you for understanding. Blessed be your holy name. In Jesus' name.
Amen.
In Jesus' name I pray.
Amen.
All right, no problem. Have a wonderful time. So tomorrow. Any question? I didn't even ask that.
No.
All right, no problem. Take care.